had a question on the limit as delta x goes to 0 of this expression, which arises when you're trying to do the partial derivative with respect to y of the sine of xy. And it would be with respect to x in this case. So that's the sine of xy. Well, there you have the sine of xy. You have the difference quotient. So you have the sine of x plus delta xy minus the sine of xy divided by delta x. And I'm not going to explain where that comes from. That should be pretty clear. It's the change in the sine due to the change delta x divided by the change delta x. So it's the rate of change of the sine function, sine of xy, with respect to x. So we rearrange this. First of all, I distribute here sine of xy plus delta xy. That's the only thing I've done here. But why did I do that? I did that because, well, I kind of know where this is going. That's how I knew what to do. But we now apply the formula for the sine of a plus b, the sine of the sum of two quantities, okay? And that's the sine of the first times the sine of the second plus the cosine of the first times the sine of the second. I don't know if I said that right, but I wrote it down right here. Sine of this times the cosine of this plus the cosine of this times the sine of this. And so I've rewritten it in terms of that simple identity. So if it doesn't occur to you to use that identity, you're kind of lost in space. Now, in proving this, you might well want to go back a year to when you proved similar things for functions of one variable, or to whenever you did this in your calculus course. And you see that if you digest that, you'll see that everything I'm doing here is completely analogous to what we would do to get the derivative of, say, the sine of theta. Okay? In trying to solve this problem, it would be perfectly valid to go back and review how you did difference quotient proofs of the derivatives of the sine, the cosine, the power functions, and reciprocal functions, and so forth, square roots. So you know what those tricks are. So you remind yourself what tricks you use. Because this is the trick you use there, and this is the trick you've got to use here. It's not a trick, it's just an application of well-known identities. By well-known, I don't mean necessarily that you remember them off the top of your head, but you know they're there, and hopefully you know how to rederive them, maybe by Euler's formula. Okay, now I'm not doing a formal proof with limits. I'm just telling you what goes on, and you can adapt it. Okay? As delta x approaches 0, because we know that we're going to take the limit of this thing as delta x approaches 0, the cosine of delta xy approaches what? It approaches 1. Because as delta x approaches 0, so does delta x times y, for any value of y. And we approach the cosine of 0, which is 1. So, we use the fact that as theta goes to 0, the cosine of theta approaches 1. Okay? And we can then, if we write this out with limits and so forth, that this can be replaced by 1. We also know, and this is a common fact that we use again and again in mathematics and physics, that for small theta, the sine of theta is approximately equal to theta. Now that's, in terms of limits, that says that the limit of sine theta over theta is 1. And you do that by a unit circle definition. Theta is close to 0. This arc distance is close to the y-coordinate of this point here. And you prove the limit very easily that way. As this triangle closes up, the arc and the y-coordinate become the same. So, we use this. And how do we use this? Well, this means that we can replace the sine of delta x times y over delta x with just plain old delta x y over delta x, okay? Or we could replace sine of delta x y, you know, it's a little fuzzy, but with delta x y, and then the delta x is going to divide out. So when you simplify this, you simply end up with the cosine of xy, which is the partial derivative of sine of xy with respect to x. Everything else goes away. I'm sorry, you end up with y times the cosine of xy. Okay, so that's it. That's a good question. I'm glad it was brought up. And the person that brought it up had most of this and was able to tell me immediately what the sine of a plus b would be. So he was right on it, but maybe didn't remember all these little ideas about limits, and especially about the limit of sine of theta as theta approaches 0.